Okay, now let's look at this graph trapezoid. The altitudes are 30 meters per second here and 34 meters per second here, and the width is 12 seconds. So if we want to rearrange this into a rectangle, we're going to go to the midpoint of the base and come up here at a perpendicular, so that we're cutting this at the halfway point of the width, okay? And we trim off this triangle here, we put it down here, and we get this triangle, so that again, we've got a rectangle of equivalent area. Okay, so now my question is, what are the dimensions of this rectangle? Okay, so you should think about that for a minute and pause, but assuming you've done so now. First of all, the width of the rectangle is 12 seconds. Okay? The height of the rectangle, well, it clearly is between 30 meters per second and 34 meters per second. This is a straight line across the top of the trapezoid. The trapezoid only approximates a graph in general. So if the graph is curved or wavy or whatever, the straight line might not be an exact, won't be an exact approximation, but still a valuable approximation if the actual graph doesn't differ too much from linear. Okay, from a straight line. Okay, so this is a straight line. Height here is 30 meters per second. Height here is 34 meters per second. You might conjecture the altitude of the equivalent rectangle is 32 meters per second, because that's right halfway between 30 and 34 meters per second. And that would be correct. Again, you have a geometric argument. The same geometric argument we saw over there tells us that the sorry, this side of this small triangle is equal to this side of this small triangle. And of course, the two sides would add up to the difference in the y values here at 30 meters per second and here at 34 meters per second. The difference in those y values is 4 meters per second. So half of that difference is 2 meters per second, so that the height here is 2 meters per second greater than the 30 meters per second, which is 32 meters per second, and 2 meters less than the 34 meters per second you have here, which is again 32 meters per second. So its answer to this question is 12 seconds by 32 meters per second. That's our answer. Okay, those are the dimensions. Another way to calculate this is simply to average these two, find the mean of these two graph altitudes, because the mean is halfway between the height here has to be halfway between this height and this height, as we can easily determine from a very similar geometric argument. So all we have to do is add this to this, and we get this. So this is the average altitude of the graph altitudes, the average of the graph altitudes. So it's both the altitude or this dimension of the rectangle, and it's the average of the two graph altitudes. Now we could put that into a formula, but I don't want to do that because I'm afraid you'll use the formula to bypass understanding of what any of this means. The connection between the trapezoid and the rectangle is so direct that you should understand every time you use this reasoning that the equivalent rectangle is going to have dimensions equal to the average of the two altitudes multiplied by the width. And you don't need a bunch of symbols to understand that. Okay, well, it follows that the area of this trapezoid is 12 seconds, which is its width, multiplied by the average of the two altitudes, which is 32 meters per second. And what's that equal? Well, 10 times 32 is 320. 2 times 32 is 64. 320 and 64 is 384. And what are the units? Seconds multiplied by meters over seconds. And of course that's equal to 384. What do you get if you multiply seconds by meters over seconds? Well, that's could be rearranged just using the rules of multiplication and division as meters times seconds over seconds. Seconds over seconds just essentially gives you 1, so this just ends up being 384 meters. Now, what's the meaning of this? Well, the meaning of this is if you are moving at 30 meters per second and then 12 seconds later at 34 meters per second, and you speed up in such a way that your speed versus time graph is a straight line, then you have to move 384 meters during that time because the 12 seconds represents the time that it took, the time interval, and the 32 meter per second average of these two represents your average velocity. If you multiply your average velocity or average speed, in this case it could be either, not going to go into the distinction at this point between velocity and speed. If you multiply your average speed by the time interval, you're going to get the distance you traveled during that time interval. Okay? So we have the time interval 12 seconds times the average speed 32 meters per second equals the distance. Now in this example, the area of the trapezoid had a reasonable interpretation. It really means something. It means that, again, if you go at 30 meters per second to 34 meters per second, speeding up from this speed to this speed in 12 seconds, and speeding up at a constant rate, as it turns out, then you travel 384 meters. Now I want to find the slope, and we've done this before, but I just do this to be complete. Okay, the slope is the rise divided by the run along this segment. The run is the 12 seconds we have here. The rise goes from 30 meters per second to 34 meters per second. So we can actually sketch that. So the rise is actually from here to here. The arrow starts here, ends here. Rise is 4 meters per second. And the run is 12 seconds. Now we could have done the run up here just as well, but I didn't have a lot of room to label it, so I did it down here near the base. But it should be clear that from this point to this point, we go up 4 meters per second, we go over 12 seconds. So the slope is rise divided by run, which is 4 meters per second, divided by 12 seconds, which is what? It's 1/3, and it's meters divided by seconds divided by seconds. Now, I'm not going to go into the detail of meters divided by seconds, but you should know fractions well enough to do this. Now, again, schools are really not teaching fractions in any significant way, so this might be a little mysterious to you. That comes out 1/3 of a meter per second squared. So the slope here is 1/3 meter per second squared. We put that in a box, and this area that we got, this 384 meters, we put in the middle of the trapezoid, and we put a circle around it. So when we see a number in the middle of a trapezoid with a circle around it, we know that represents the area of that trapezoid. And when we see a box above the sloping segment on the trapezoid, we know that represents the slope. When we see a quantity next to one of the graph altitudes, we know is how big that graph it is that graph altitude. And if we see a number down here, we know it's the width of the trapezoid.